All right, we're going to see if these Colby students can hold a candle to these Waterville and Maynard students. I think they can. I think you guys can do it. I have some faith. Yeah. I think they'll do it. It's a very high bar. It's a very high bar. With that, don't let the butterflies get you.
Yeah.
Go for it.
All right. How's it going, everybody? My name is Will Reynolds. This is Graham Bennett. And we're going to be talking about the physiological and neurological effects of arsenic on the body. But to start this off, I'd like to tell you a story about someone named Mary Ann Cotton. Now, Mary Ann Cotton was a mother of over 10 children in England during the 1830s. And over the course of her lifetime, every single one of her children contracted something called gastric fever. And funny thing about gastric fever is that within 4 days of contracting it, every single one of her children passed away. Now, at the end of Mary Ann Cotton's life, they found out that Mary Ann Cotton was actually poisoning her own children. Now, the reason I'm telling you this is to show the extreme danger of arsenic. This is something that was commonly used as a poison and is something that is in our drinking water right here in Maine. And luckily for us, these are very, very high doses of arsenic that are extremely rare in the environment. They're not naturally occurring, so it's not something we have to worry about too much. However, in extremely low doses, like we heard earlier, concentrations of 10 parts per billion, arsenic can still have a really negative effect on the body. To get into the science a little bit, the reason for this is that arsenic has a very similar valence structure, similar molecular structure to phosphorus. Now, phosphorus is an extremely important molecule to life. It's very important in the synthesis of DNA and many other things in the body. Because of this similarity in structure, arsenic can dislodge some of the phosphorus systems within the cells in the body. And some of these systems are involved in the synthesis of DNA. And because of this, arsenic is one of the most deadly carcinogens that can cause all sorts of cancers, as we heard earlier. So Graham is going to tell you a little bit about the neurological effects.
Hello, everybody. As stated previously, it can cause heart disease, skin lesions, all those nasty pictures you showed us. And it is related to pathologies found in Alzheimer's, peripheral neuropathy, which is just numbness in the fingers, you can't feel anything. And it can cause changes in behavior, memory loss, both short-term and long-term, depression. It can lower intelligence, slower processing speed, and it is very bad for the development of children, in the development of children. But there are ways to treat these should you already be exposed to chronic arsenic exposure. I'm sure you're all fine, though. The carcinogenic properties can be treated by selenium. That's an element on the table. Important part of the human body. It is a known anti-carcinogen. So all of this research comes from India, which is dealing with the arsenic crisis themselves. And zinc is good at preventing birth defects related to drinking contaminated water for pregnant women. High protein diet, antidepressants, curcumin, and Prozac can all help with chronic exposure to arsenic in the behavioral section. But more studies are needed to find the ways the arsenic affects on the brain. It reduces processing speeds in children, and children perform poorer in visual spatial reasoning tests, math, memory, vocabulary, intelligence. And you have an increased risk of mood disorders, as already stated, depression, and ADHD.
So just exit out of this guy.
Yeah.
Hi, I'm Hannah,
I'm Ben.
and today we're going to be presenting on the economic and historical considerations of arsenic. So, arsenic is a naturally occurring metalloid that is found in soil, water, and air. The present day English word arsenic has been adapted from the ancient Greek word arsenikon. So, around the early 16th and 17th centuries, arsenic gained a status of a notorious poison used by emperors to kill their rivals. It eventually gained a reputation of a high profile poison after the death of Napoleon Bonaparte in 1851. Its symptoms were confused with common diseases such as the plague and cholera. So, this cartoon depicts a famous case of arsenic poisoning that occurred in Bradford, Maine in 1858. So, the confectioner Joseph Neal, who usually replaced parts of sugar for the peppermints that he made with plaster of Paris, which was a widely practiced and harmful adulteration process. However, on this occasion, instead of using plaster of Paris, he unknowingly used arsenic. And because of this, over 20 people died and many people became very ill. And during this time, food adulteration flourished because it was a way to cut costs and increase profits. So in World War I, arsenic was used in the form of a poisonous gas by the U.S. Army. Lewisite and amosite, both forms of arsenic, were the types of poison that were used in this time. And finally, arsenic today. So humans today are affected by arsenic because of its toxic properties. As I previously mentioned, it was used as a poison and caused the death of many, many people. So it's obviously not great for humans to ingest. So workers working in industries and people who drink or breathe arsenic in contaminated water or air usually have an increased risk to various kinds of diseases such as skin cancer, bladder cancer, as well as Blackfoot disease. Arsenic over the years has been used as a pesticide, chemotherapeutic agent, and in cosmetic products, so it has been used in a variety of different places.
All right, so I know change gears slightly to talk more about some of the economic effects and a little bit about policy. So to start, I wanted to talk about the inequality of arsenic. And when I'm talking about the inequality of arsenic, I'm not talking about necessarily a difference in how arsenic is like divided in terms of socioeconomic status. So across socioeconomic levels, you see like the same occurrence of arsenic, but the way in which um, households are able to treat or like mediate the effects of arsenic in terms of filtration and well testing do vary across socioeconomic status. So I'll begin basically by saying in 2001, the US EPA revised the maximum contaminant level to 10 parts per billion. Um, and basically at that time, they published a study and they were doing all this research. And in that research, they admitted basically that a limit of 3 to 5 parts per billion would have actually had by far the greatest public health benefit. But in doing that cost benefit analysis, they determined that a ratio of like 10 or 20 parts per billion was more feasible and in the end had a better like cost benefit when they did that research. And so you can see in this graph right here, in 2001, that standard was revised and it went into effect in 2006. And you can see sort of when it went into effect, this jump in violations of that revised standard. And so what you see is that households with a lower median income were unable to meet this lower standard. So you see a higher rate of noncompliance than you do in families with a higher median income that can afford well testing and can afford. So I wanted to do a bit of a deeper dive into that economic cost benefit analysis. And this is based on a case study in West Bengal, India. an area that is suffering from a lot of these same arsenic use. And so in this study, they're basing it on a safe limit of 50 parts per billion, which is obviously a lot higher than the standard here in the US. And in their research, they found that reducing arsenic to that limit would result in a $7 per month benefit. And they did that by basically letting sick days and medical expenditures be a proxy for utility. And that benefit is derived from lost wages, saving money on hospital bills and things like that. And they compared that to the average cost of supplying filtration in this region, which they determined to be about $3. So you can see from these like very basic figures that there is going to be like a $4 benefit in the long run to filtering your water for arsenic. So obviously this is in a different region. This is not for Maine, but you can see like the basic idea that if you put that like money up front for filtration, you're actually going to see like a long run benefit. And a big takeaway from this study was that households were willing to pay that upfront cost when they were shown what the economic benefit would be in the long term. And most importantly, perhaps, that showing households this monetary benefit of reducing arsenic might be better at inducing them to test their wells than showing them, say, what the health risk would be. Okay, so moving on to policy solutions, I'm going to just quickly compare New Jersey and Maine. So New Jersey has actually succeeded in passing some legislation to regulate well testing. In 2002, they passed the Private Well Testing Act, which required that at the time of a real estate sale, you test your well, and that did it all public information. So you can see this map right here is actually just taken from like this Private Well Testing Act website, and you have access to this information. Anyone looking to buy a home in New Jersey can see where wells have been tested and what that data shows. And so there's some concern with things like this, especially here in Maine, and it was at the time in New Jersey, that this would have an effect on real estate values. People who test their wells and it shows high levels of arsenic might be like averse to this, but they came to the conclusion that like if this is statewide, then all buyers are just going to be better informed. And as you can see, it's basically showing like a rough grid, and you can actually identify individual households within that. So in Maine, Maine has yet to succeed in passing any like legislative attempts to require well testing. And the difference between what Maine and New Jersey, there are a few things there. One is that in New Jersey, a lot of the arsenic is due to industrial pollution, whereas in Maine, you see a lot of it is naturally occurring, as my peers will talk about. And part of that means that people are often more averse to government intervention in private wells because it's not necessarily like firm coming in and polluting that arsenic. And so people are a bit resistant to government involvement and have concerns, legitimate concerns about real estate prices. And so something that people in Maine and the government in Maine needs to decide is sort of whether government should have a role in requiring testing. But there are certainly many other ways to, fix this problem of arsenic exposure and like mitigate that risk. Yep.
Is this you guys? It's okay.
Great. Hi everyone, I'm Josh.
I'm Amanda.
We're going to be talking about the geographic and population prevalence of arsenic, both internationally and in the U.S.
So before we get into sort of where areas that are affected, and can you just... Okay, so before we get into exactly where there are higher levels of arsenic, I think it's important to talk about the geological features that create these high prevalences. So there's been a lot of recent research that focuses on the relationship between bedrock, geological structures, and groundwater. And the results suggest, and this project has contributed to some of this research, which is pretty cool. The results suggest that arsenic can become highly concentrated on areas of faults and in areas with high levels of bedrock. So as you can see in this map here, that red line sort of corresponds to some of the fault lines, and it's also in that area where there is a lot of bedrock within Maine. And specifically in Maine, there's a lot of schist rock, which is a type of metamorphic rock that's often found where tectonic plates collide. So what happens when tectonic plates collide is that the rocks are under stress, they're under pressure, they bend and fold and create these cracks. And it's within those cracks that groundwater often collects, which is where we get a lot of our well water from private wells. It also is because of those collisions of tectonic plates where a lot of minerals that contain elements such as arsenic are deposited. So we're drawing that well water up from these bedrocks that contain high levels of arsenic often.
Great. So where does that happen and who does it happen to? In the U.S., it's most common in the Southwest, the Northwest, the Northeast, and Alaska. Internationally, it's very prevalent around India, Bangladesh, Vietnam, then also in Chile and Mexico. And so we're mostly going to be talking about natural arsenic prevalence here. Obviously, as other groups have talked about, there is a huge part industrial from smelting and from wood preservation. But that doesn't necessarily get into wells, except for the dug wells. And so we're going to be focusing on the stuff that's in the bedrock itself. And the real reason that it's a problem in private wells and rather than public water is because private wells aren't held to the same regulatory and inspection regime that public waters are, and thus are more likely to contain it. Across the U.S., 44 million Americans rely on private wells, and of that, about 2 million of them, or about 5%, are at least predicted to have higher than EPA standard levels of arsenic in it. In Maine itself, it's a double whammy. As I actually just learned and updated information about, apparently 56% of people in Maine depend on private wells. But, and then again, it's almost double the national average on what the EPA limit is. That level of prevalence of arsenic is really concentrated in, as you can see, the southern and central coast of Maine, as well as Kennebec County, where we are. And like Ben mentioned really briefly, arsenic prevalence is socioeconomically random, which means that poor people aren't more likely to live in areas where it's particularly prevalent, and that's likely due because of its invisible nature. However, there are significant disparities in the effects of arsenic in groundwater, and that's because of their people's ability to test, both ability and knowledge to test and then remediate those issues. And so there's a really interesting study that was done both in New Jersey and in Maine, looking at the effect of income and education on how likely a person is to test their well for arsenic. In Maine, it was every $20,000 in household income was seen as a 7% increase in the probability that they would test for arsenic. A bachelor's degree would be another 23% more likely. And the amazing thing about that is that only 92% of that disparity was just looking for arsenic in their last well test. It wasn't like an individually commissioned study to look for arsenic in their test. It was just part of a standard maintenance regime. And then, yeah. And along with this level of education and just knowledge about arsenic, something that was really impactful when I read was a study that showed that 6 years after a set of families received the information that their arsenic was above 50 parts per billion, which is again 5 times the EPA limit, 27% of those people took no recourse, and that was due either because they didn't see it as an issue or because they didn't have the resources to take care of the problem, both pointing to problems and disparities about resources and about just knowledge of. And then we're going to talk about a little bit in Bangladesh as like a worst case scenario.
Yeah, because obviously this is an international problem, and arsenic levels in Bangladesh are extremely high. We see that connection with the fault lines, as arsenic is prevalent in the fault lines in Maine. It is also prevalent in these areas of high fault lines in Bangladesh. A survey conducted in Aresnic, Bangladesh, which is right around that central area, sort of the Indian border, found that over 60,000 residents surveyed, of those residents, over half regularly consumed well water with arsenic concentrations greater than 50 parts per billion, which is high above the accepted government standard in Bangladesh and, of course, in the US. Again, as Josh said, there was no correlation between socioeconomic status of individuals and the geographic prevalence of well water, but I think it's important to note that the awareness of individuals was significantly related to many demographic factors, such as better housing conditions, higher socioeconomic class, non-labor occupations, and gender. So although there aren't those geographic relations, the awareness is highly correlated with willingness to change and reduce exposure, suggesting that those populations are more highly affected by arsenic poisoning and higher levels of arsenic because of this lack of awareness, which I think just points to the idea of how important it is to educate all of the population, which I think is also just as probable and important here in Maine as it is in Bangladesh.
Absolutely. I think we both came away from this research very glad that this program exists. This is really doing its job. Thank you so much for listening.
Thank you.
Hi, everybody. My name is David. I'm going to talk to you about arsenic prevalence in your food, just briefly. So we've talked a little bit about what arsenic is today, but I want to talk about how there are actually two different types of arsenic. You have organic arsenic, which occurs when it's combined with carbon and hydrogen in nature. And this is actually non-toxic and non-harmful to human beings. This is why when people say there's a lot of arsenic in seafood, for example, it's almost entirely organic arsenic, and why we don't really have to worry as much about seafood consumption. On the other hand, inorganic arsenic occurs for a number of reasons, and it's from a combination with oxygen, chlorine, and sulfur. And you'll see this from both naturally occurring in areas where there are these ruptures in the earth, as we were just talking about, or from the use of herbicides and pesticides, which, although this no longer takes place, I will talk about how a bioaccumulation effect can still affect the lands where herbicides and pesticides were used in the past. Additionally, arsenic is smellless and tasteless, so that's part of what makes it a good poison and why we have no idea when we're consuming it. So as I was talking about, arsenic ends up in our food a couple of ways. You have these areas which are naturally high in arsenic in the soil itself, and this is often from these sort of tectonic plates shifting and just the arsenic in the soil kind of leaking up into the land and being absorbed by the fruits or the herbs or the vegetables that are grown on that land. But in the past, we also had a lot of herbicides, pesticides, fungicides, which had inorganic arsenic in their makeup. And as a result, the plants would absorb it. While this stopped being done in 2006, other than in cotton, where we see some organic arsenic used as a pesticide, there is still some bioaccumulation effects in the soil, and that's why you'll see some apple orchards, for example, which, if they used to use herbicides and pesticides on the land, still show levels of arsenic. So a few fruits and veggies that are not dangerous, even or less likely to be dangerous, even when grown on arsenic land, are fruiting crops like tomatoes, peppers, squash, cucumbers, peas. List goes on up there. Leafy vegetables do have slightly more arsenic stored in the leaves, but not to a level which is determined to be dangerous. And while root vegetables with peels on them do store a lot of arsenic in the peels, if you go through your basic kitchen practices of washing your vegetables and peeling them, you should be all right. On the other hand, fruits like apples, pears, and grapes tend to absorb a lot more arsenic. So if these are grown on lands with high arsenic content in the land, you can end up with a lot of arsenic in the fruit. It's a common misperception that with fruits like apples, that the arsenic is actually stored in the seeds. In fact, this comes from the fact that cyanide is in the seeds of apples, although the shell on the seeds protects you, so you don't have to worry about that either. It's in the fruit itself, and that's why when you have juice, if anything you're worried about with arsenic in juice is just from the fruit being crushed up. This is why with children you should avoid significant servings of juice to avoid arsenic effects on children. Also, apparently, if you've ever had a pawpaw, they tend to be very high in arsenic content. Finally, I'm going to end with talking about rice. Rice is another food that shows pretty high arsenic content levels, and this has to do with it sitting in these rice paddies, which are basically these flat areas of land which are filled with water. And if the water in the area is high in arsenic, the rice is basically just soaking up this arsenic. So ways to avoid this have to do with looking at areas which are higher or lower in arsenic content. Like we talked about before, Bangladesh and other parts of Asia tend to be very high in arsenic. So rices grown from these areas tend to have higher amounts of arsenic in them. Arsenic tends to be stored in the shells of rice more often. So while brown rice might have other health benefits, white rice is actually going to have much less arsenic content in it generally. So if you just vary your grains, soak and rinse your rice and cook it properly, you should be able to get most of the arsenic out of it. And by using rices which are grown in lower arsenic content areas, which you can find that data online fairly easily, you should be able to avoid most arsenic in rice. Thank you.
All right, hello everybody. I'm Zachary.
I'm Theo.
So we're going to be talking about the prevalence of arsenic in drinking water. So like some other groups have told us already, this is a really global problem. It's a lot of countries around the world have really high prevalence of arsenic. One example is China. This map here is of the Jinghui Irrigation District in northwest China, in the Low S region, and just the darker purple areas are the areas that are more affected in this map. So this study found that 2.58% of the water in this region has dangerous levels of arsenic. And according to the World Bank, the Low S region has over 50 million people living there. So if you extrapolate that number to the entire Low S region, that's well over 1 million people that will be drinking arsenic with dangerous, or water with dangerous amounts of arsenic in it. So it's a problem all around the world and also here in Maine. I'll keep this part brief because we've heard from other groups about, we've seen these same maps, but basically it's very prevalent here in Maine. And another part of the issue is that even when people are informed that they have arsenic in their drinking water, a lot of times they don't do anything about it. A study done here in Maine in 2015 found that of households that were informed 2 years earlier that their drinking water had between 10 and 50 parts per billion of arsenic, 31% of those households did not act, did not, go to Target and buy a zero water filter. And with households with greater than 50 parts per billion, 11% of households also did not act. So, yeah, it's very prevalent, and a lot of people aren't really taking it.
So arsenic is predominantly an issue in wells, and we don't really see it as an issue in public water sources because there are really stringent testing protocols and oversight for public water sources. But bottled water actually doesn't face the same regulations. This is coming from a report in 2019, and so Penefiel water, which is made by Keurig Dr. Pepper and bottled in Mexico and sold to the U.S. market, was shown to have an average of 18.1 parts per billion, which is almost double the recommended dose. And then Starkey, which is Whole Foods brand of bottled water, had 4 samples that were at or above the safe limit for arsenic. And so the really interesting thing about both of these is, so this report was published, this was brought to the awareness of the corporations that manufacture and sell these water, and neither entity has recalled their water, so they have said in public statements that we believe our products are safe and our testing regimens are adequate. And the FDA also, with the Penefiel, which has obviously a much higher concentration. So with the Starkey, it was 9.4, 9.7, and 10.1. But with Penefiel, it's 18.1. The FDA has also declined to issue a recall on that water. So, how does it get into our groundwater? 2 main sources. I'll keep this brief because it hits on what a lot of other people have said. There are natural and anthropogenic sources. So what we find is that arsenic is mainly tied to sulfide minerals, and sulfide minerals are metamorphic. So we find higher concentrations of arsenic in metamorphic rock. So the blue band in figure 1 are areas that have metamorphic rock, and we find 3 times the national average of arsenic in that blue band. And then in figure 2, this comes from a study that was conducted in 2011 in Spain, looking at arsenic in different types of rock. So the key takeaway from this is in figure 2, this is of arsenic in the actual rock samples themselves. And in the second histogram, so histogram B, we find that in metamorphic rock, there's a higher average of arsenic. So then anthropogenic sources, copper smelting is the #1 source worldwide, produces 62,000 tons of arsenic per year. And so just for reference, 100 milligrams of arsenic is enough to be fatal. Coal in the United States, the burning of coal ash is a large source of arsenic here in the United States, and then treated wood and herbicides, pesticides, and insecticides. So yeah, that's all we have. Thank you very much.
Hello, everybody. I'm Alex.
I'm Mariana. I'm Julia.
We decided to talk a little bit about remediation, mitigation, and filtration, so how to remove arsenic. So originally we were going to talk about all these different types of removal, but today we're going to keep it a little bit shorter, and since a couple of the other groups already went over ion exchange and the membrane processes, we're going to talk mainly about adsorption, which is one of the most economical uses for the removal, and also more on household filters that you guys can use to mitigate the amount of arsenic in your well water. I wanted to show this slide to just show you how many different types of filtration methods there are. Clearly, there's a lot of types and subtypes of all these processes, so keep that in mind that there isn't an exact way to get rid of all kinds of arsenic, but there's a lot of science that goes into trying to find the best way to get rid of it. So just a little bit about the history before I get into the science. Carbon extends far back in history. Charcoal, which is a type of carbon, was used in India for water filtration, and it was also used as a medical absorbent in Egypt, and also in the 1900s used as a activated carbon was used mainly for sugar, but the first reported use for water treatment was until 1930. So to get into absorption, the process, the science of it is an electrostatic binding of soluble arsenic to external surfaces of the insoluble metal hydroxide. So clearly a lot of science mumbo jumbo, but it's the most popular absorbent, and that's activated carbon. I'll get into that in a little bit. But the reason it's so popular is mainly because of its economic factors. It's probably the cheapest. This is strongly affected by pH. If the optimal pH value for your water is usually 6, but if it's strongly alkaline or acidic, that can affect how much remediation happens in that arsenic. And also the disadvantages to absorption. In disposing the spent media, there's obviously some concerns with the toxic nature of that arsenic. So I talked a little bit about activated carbon. What that really is charcoal that's heated or treated in some way from wood, coal, lignite, or coconut shell, and it is put into that water and used for its purification.
Okay, so in discussing what we can do to prevent and control arsenic levels, if there are a lot of household filters, if you don't want to rely on community filters or lack thereof, so you can, first of all, you can substitute high arsenic sources like groundwater with low ones like rainwater, and low arsenic water can be used for, or only used for consumption, whereas you can use high arsenic water like bathing and washing clothes.
Okay, so there are two main types of household filtration systems. Just kidding.
So just generic household filters will remove bacteria and water contaminants, but to actually eliminate arsenic, you need a system that will specifically treat the water. So here are just some numbers about the different methods and how effective they are in reducing arsenic.
Okay. There are two main types of household filters. And so you have the point of entry systems, and then you have point of use. Point of entry systems cover so these are usually in the basement or that kind of thing. And those are two different filtration jugs, I guess. The first one is the working system, which does all of the work, as the title says, and the arsenic. The second system is the safety system, and this is for any arsenic that gets through the working system. And so that system covers all of the faucets, showers, all the water in your house, and it takes a few hours to install. And of the cost for the whole thing, the installment is the most costly part of it. However, once you have installed it, its maintenance is every few years you have to get the filter replaced. So if you think about it in a long-term way, it's about $1 or a little bit less than $1 a day for having one of these systems. And it also increases the value of your home. Some friends talked about. But then, sorry, point of view systems. This is going to be a single under the sink filtration system. And so these ones are usually placed in the kitchen. And it basically just makes your kitchen water or whatever sink you put it under drinkable. You have to get these ones maintained annually. So you have the downside of that as well as the downside of the fact that you only have one sink in your house that is drinkable. However, like Julia previously stated, showering and using water that isn't filtered for washing your clothes and stuff like that is fine. So the one thing you have to be kind of careful with is like brushing.
Okay, so I have a couple of examples of household filters. So this one is, well, household filters can range from anywhere from like a couple hundred to even like $10,000. So this one is on the cheaper side. It is low maintenance and long lasting, and it works in kind of like a backwash process where the water is like filtered on an automatic system, and then it removes arsenic as well as heavy metals. And then here's another example. This one is a lot smaller. It comes in 3 sizes depending on how much water filtering you need for your home. And this one works in a similar way where it just flows the water and it goes through like a filter cartridge and it reduces the arsenic and heavy metals. Thank you.